Okay, so as long as these little ICs, these little integrated circuits, as long as they need external peripherals to be of any practical use, as long as they have configurable perimeters that need external components to set specific values for these tiny little radios and computers and micro components, as long as these things need external microphones and audio filters and speakers and things hooked to them to be of any real practical use, people like me that do this sort of a thing for a living, I think we're always going to have a job. Because capacitors are always going to short, resistors, things, they're always going to get wet. Things are always going to happen that causes this stuff to mess up. And as long as this stuff is built this way, I'm never going to have to eat out of the trash can again. Now, with all that being said, as long as Apple continues to use long screws next to short screws, people are always going to do this to phones, and I am never going to have to eat out of the trash cans, ever. So, today we're going to be working on an iPhone 7 that was sent here for no image after something. No image or no backlight. We're not exactly sure what it is because I haven't went and read to see what the original story was, because 9 times out of 10, the original story, it's not going to help you. Let's see what we are up against. I'm going to switch you over here and show you what this looks like under the microscope. This is an iPhone 7 that was sent here for no image or no backlight. And the first thing I seen before ever even looking at this under the microscope is this, like, round hole. Oh, and by the way, I gotta watch talking about LSD and screw holes in the same video because YouTube's been slapping me on the hands for that. No, I don't know why they've been doing that. That's they've been doing that to Paul Daniels as well. They showed that my video is not suitable for all advertisers, which I totally understand that. Like, sometimes I wonder what you can get away with on YouTube, but then you watch, like, I don't know, just pick a random popular gamer and watch 30 seconds of any of their videos and see if you can count the usage of the word fuck and, like, just 30 seconds, and you'll find out that Rossman and Jessa and everybody just kind of looks like angels on YouTube. So let's see if we can fix this damn thing. I'm going to switch over and see if ZXW Tool has anything to say about iPhone 7 screw holes. Man, when I sat down to record this video today, where's my buttons at? Okay, when I sat down to record this video today, I honestly believed that I was going to be doing like a backlight filter or, you know, a shorted cap somewhere. I did not expect to open this phone. That's a 7 Plus. We don't have anything about screw holes on the 7, right? All right, am I missing it? We got iPhone 7 Plus, 7 Plus screw holes, 7 Plus again, iPhone 7. We don't have anything here for long screw damage on iPhone 7, so that means I don't know what to do. If ZXW Tool won't tell me how to fix it, I'm completely lost. Who needs money anyway? We'll just throw this one aside. So what are we going to do here? Let's open up on ZXW Tool what it will show us. Let's open up the iPhone 7 and get back down in here and have a look at this completely mutilated phone. Alright, so we've got that opened up. Let's zoom in down here at the bottom. And it is BS0405, so that's bullshit 0405. This screw hole here. Here nearby we have a resistor 1V8 touch. That's going to be, oh, probably a pull up the way that's arranged. I'm just guessing. And we've got FL3910. That is also related to touch. And I'm gonna go into my own little world here and peel some stuff back because my number one priority here is solving this problem. And so far, I'm not at all convinced that I'm staring at a problem that I'm not going to be able to solve. So as it is right now, I am planning on returning this to the customer as a repaired phone and sticking my neck out, way out, that this is the only thing wrong with this phone. I can tell you it looks like it has been worked on with a wrench and a screwdriver because whatever this IC is over here has also been busted off here at the corner. I have no idea why. Well, I do know why. There's been a pry tool under it. I just don't know why there's been a pry tool under it. All right, so let's zoom back in here and see about this screw hole. Now, it looks like one of the components here we see on ZXW, that's going to be a no stuff. Okay, let's get ZXW back on the screen. What I'm looking for is nearby components. This one also pertains to touch. I'm looking for nearby components that are going to give us a no image or a no backlight situation. Unless, you know, what are the odds? What are the odds that we've got this screw hole tore all to hell like this, and this problem is actually being caused by a blown backlight circuit? What are the odds? What are the odds? Let's hook power to it. I'm going to use my screen today because I don't trust anything that they sent with this phone. Let's see, iPhone 7. There we go. Let's move the microscope out of the way. And let's show you a little closer here the bench. So this is an iPhone 7 screen that I know works. Well, it worked the last time I used it anyways. And this is their iPhone 7. Let's get all this bubble wrap out of my way. Now, I don't have a lot of donor parts laying around for the iPhone 7, but a lot of the components are and have been the same. There we go. And why it is that these iPhone 7 screens are so cheap, I don't know. I'm not in the screen replacement business. So we're going to be running this off of the DC power supply because we need a bit of a pulse. Like we need a heartbeat. We need to know what this thing is doing. I believe you'll be able to see my power supply and see the iPhone 7. And we're going to plug in the one here that's labeled iPhone 7. And is it going to smoke and fire? Is it going to what's going to happen? All right, 4.2, 4.3, which that supply is a little low. I've checked it. It's not putting out 4.4 volts. It's more like 3.9 right now. So, all right, I'm going to hit the power button and we get half an amp. No, wait, that was 50 milliamps. Now we're at 100 milliamps. 160, 600 milliamps, 300. I'm going to say this phone's booting. All right, I'm going to spin the microscope around here and shine a little light on it. Okay, this is actually no image. This is booting with no backlight. Well, now it's off. All right, so let's shine the microscope on it and look really close. This is no image. So today we're going to be working on an iPhone 7 that has been long screw damaged and has no image after a screen replacement. So that is actually what we're up against here. Betcha. All right, so let's disconnect my screen. And go in for a closer look because now I do believe that we are after an issue here caused by long screw damage. But it could be anything. It could be absolutely anything. Let's put a drop of alcohol on our screw hole and see what we can reveal. Drop of alcohol. Come on. Uh-oh, I lost it. There it is. Okay. You forget how small this stuff is when you're working on it every day, and you try to look at it without the microscope. For me, it's just like it's a blur. Oh dear Lord! Oh, look at how many traces are in that. Ah! Did you see how many traces are in that? Oh no, no! Dear Apple, please remove all screws longer than a point whatever millimeters from all iPhones, or start offering data recovery services. Okay. Man, that's been a really nasty cold. Alright, so is the no image problem on this iPhone 7 caused by this screw damage? What's the test point? What's the test point nearby? Surely that's power related, right? So far I have not seen anything over here that would give us no image, because everything so far is pertaining to touch. That test point is ground. This is 1v8. Wait a minute. Do we have something really, really funky? What's this IMU? Maggie. What does Maggie do? Should I know what Maggie is? Does anybody else watching this video already know who Maggie is? Because I don't think I know who Maggie is. I think Maggie might be a hag that... Excel gyro. I was thinking maybe Maggie's a hag that could give us issues with image. Judging by some of these pins, this is going to be accelerometer and gyro, I bet you. I don't think that's going to cause us an issue. Okay, so right also here nearby we've got our LCM reset. Now, you know, you figure for this connection here to make it up to the CPU, we've got to have traces moving through here, right? So let's go ahead and open up Blackfish, and I'm going to verify just to, you know, I might look dumb, but I'm going to verify Maggie is going to be our accelerometer. U2404. Maggie, you little hag, are you causing this phone? Did you cause this user to long screw damage this? What did I say it was? U2404? Alright, so here is Maggie. Yeah, this is gyro 2, AOP det ready. Okay, so I don't believe, from what I see here, I don't believe that this is going to have anything to do with image. I could be completely wrong. I might be totally wrong, but I don't think this is going to be image related. So wait, this is also the same IC, right? No, different IC. Different spot on the board. What is that? Where's U2401 at? Down there. Or up there, whatever. Okay. Okay, guys, back over to this screw hole. As soon as I find it again. Because now I'm all lost on the board here. So we have an iPhone 7 that gets no image on the screen. Everything along this side of the connector seems like it pertains to touch. Nope, that's power for display. And we've got a capacitor here, but we know that this line, this 5V7 line, this is going to have a filter on it somewhere. The next pin This is for touch. 1v8 LCM con. So, okay, now this could be an issue. If you don't get 1.8 volts coming to the display is not going to send a signal back to Chestnut to turn on. So we could have an issue here. See how we've got pin, and also we're doing this without somebody like telling us which traces are under that screw hole that could cause an issue. We really don't know what's up. But if we look here, we've got 1357. So the fourth pin from the left right here is the 1.8 volt line coming to the display, and then its anode side of this capacitor over here is right up against our severed screw hole. So let's go back over here to the microscope and look just a little bit closer at that capacitor and see if it's got any give. I think it's this one right here, right? It seems pretty solid. And is this on the con side? It is. So with the amount of manhandling that's been done to this phone, it makes me wonder if this could have potentially been shorted nice and firm and blown the filter on the other side. I'm going to take a couple of resistance mode measurements to ground. I like to use resistance mode measurements to ground because I'm old school and I don't think in diode mode. But as far as resistance mode measurements to ground here, it will tell us if anything's severed, because we should get something, some path to ground. Okay, now if I touch my probes together, we get 0, 0. Now I'm going to put my left probe on ground, that's my black probe, and I'm going to put my red probe on the 1v8 line here, and we get 40,000 ohms. To me that seems reasonable. Now we're going to come over here and I'm going to check, which pin was it? It was the first pin, second. Okay, so the first 4 pins here, they're all for power, but the first one is power that would prevent us from getting an image. Now that is at 300,000 ohms. I'm typically used to seeing that at closer to 50,000 ohms. I'm not sure why that's that high, but it could have something to do with this being an iPhone 7, and I don't just work on iPhone 7s all the time. This is still a fairly new experience. First long screw damaged iPhone 7. So what do we do from here? We could, since that cap is way over there, we could actually get to it with the screen hooked up, but the 1.8 volt line, that should have something going on the screen anyways. So what I'm going to do now, I'm actually going to go ahead, I'm going to hook the power supply back up to this phone. Like that, which would make it a bit of a chore to get down to that pin. So we're going to the cap that's on 1v8. So I am now pushing the power button. And we are drawing 100 milliamps. This phone is actually booting. And I'm going to check for voltage on the 4th pin over here at the connector, which should give us 1.8 volts. And it did right before the phone shut off. Yeah, we've got 1.8 volts at the connector. So we know the 1.8 volts is getting there. We don't know about these 5v7 lines. Those are a little bit more tricky to test because in the iPhone 6 and 6S world, you have to have a display hooked up in order for that line to be powered. So I'm going to go ahead and try to make it a point to do this in front of the camera. Okay, we're going to hook our display up. Okay, and where was that 5v7 cap at? Oh, it's right next to the connector. I can't do that. So we got our 1.8 volts there. Okay, folks, the next step from here is going to be to pull the board, because as we can see here on ZXW, we've got see how we've got this 5v7 con. In these schematics, when you see that con, that means it's on the other side of an inductor, and there's no inductor on this side of the board. So if we switch over to the other side of the board, I'm betting that we do have inductors. And we do. So here is the filter for that line, and on the other side of it is where we're going to have our chestnut output from. This is going to be the chestnut IC here. So there's really not much different here from an iPhone 6, iPhone 6 Plus, 6S, 6S Plus. It's really sort of the same ball game. It's just shaped different. So let's go ahead and pull the board out of this thing and see what we can do. I bet to pull the board out, I do actually need my handy dandy tri-wing, whatever they call it, driver. If you just type in iPhone 7 driver or something, you'll probably find it. So where's his... Oh, that's right. I haven't taken out a single screw yet, so we don't have a magnet pad. All right, let's get the board out of this thing. And see if I can't figure out why it doesn't have an image. Common sense would suggest it could have something to do with the gaping screw hole, right? But logic and what I'm seeing here doesn't... Did it break a connection from the forward side to the back side? Is it not the area directly under the screw hole at all, yet the area around it from it pulling the PCB apart? You can wind up with all kinds of weird things wrong from long screw damage. So let's get that out of the way. The autofocus here might be maddening, but I'm not going to fix it right now. I'm going to fix this phone and move on to my next repair. Now, I will say that I am proud to announce that I'm faced with reasonable turnaround times again. I have recently lowered the turnaround time on routine repairs to 3 to 7 days. And what I mean by routine repairs is if it comes in and it has not had like prior hot air rework attempts, and it's like no image after screen replacement, or touch failure, things that go wrong that have not been attempted to be repaired yet are typically the things that I consider to be routine. But a touch IC repair that's already had a prior repair attempt, that is no longer a routine repair. That's way, 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 way outside of what I would consider to be routine. All right, let's set this little guy over here. We've got a couple more of these standoff posts. Hey, we've got a missing screw hole, so once again, less work. All right, get that out of there. I tell you what, it really has felt good to go back to being really, really like clean and have a set, steady pace with repairs. High volume really, really, really gets to be a drag. It can frazzle you out, and here lately I've managed to slow things down to the point where I am able to repair this stuff at a nice pace to where I know that the job's getting done right. Nothing's getting skipped, which, I wasn't skipping anything before either, but, sometimes I like to make it just a little bit cleaner, or go back and do that one other thing, or clean the camera lens. Whenever I was doing, where the hell's the SIM tray at? Oh, my eyes are messing with me. Whenever I was doing all local walk-ins, I all the time took pride in being able to do a little bit more. It came in for the charge port to be fixed, but their front camera didn't work because it's got hair all in it, and it's, whoever did the screen replacement did a really piss poor job. So it's feeling really good to get back to the point where I've got time to address other things like that aren't just like completely related to the repair. It's a good feeling. I like doing stuff like that. And whenever the volume gets to be too high and things get to be too crazy, it's really, really difficult to do that, to do that sort of a job. You just got to get it done and move on. So Now to get into the, do we have to peel the sticker off? Let's see, that first filter is in an area where I don't have to peel the sticker off. So let's move in. We're going to have a look at that filter first on ZXW tool. We were after this 5v7 line here, PP5v7 LCM AVDDH underscore con. That's the filter that we're after right now, and we can get to that without tearing it apart. So, let's see, where'd my blade go? We've got this IC here, we've got cap, and then we've got 5v7 filter there. So what we're going to do, I'm going to check that for continuity and see what the continuity is across this filter, and we get 1.2 ohms. I would say that's acceptable. So let's move on to the top side of the board once again. We're going to skip that. LCM con. We know we had 1.8 volts, right? Sometimes those 1.8 volt filters, they'll read an ohm or less than an ohm, but it's not, they're still bad to the point where you get no image. So we may have to address that filter as well. Let's check it anyways, okay? So this is the fourth pin over. We should have a 1.8 volt filter somewhere. Okay, now this one's going to be way over here. Let's mix it up a little bit, Apple, shall we? So to get to that one, we are going to have to peel this sticker off the bottom of the board. Okay. There's a component there that looks like total garbage. Oh, this head colt's got me down. I'm trying to be upbeat and chippery for my iPhone 7 repair video, but this head colt has really got me down. I think I brought something back from the swamps. You know what? That's going to be FL. That's going to be it. So if we look at ZXW tool, we got FL 3906. And we're going to get in and check that for continuity. Now remember we got 1.8 volts at the pin, you know. And we're going to get in and we're going to check this black looking filter for continuity, and we get 8,000 ohms. So if you look at ZXW tool, this is a ferrous inductor, and we should get maybe an ohm across this thing. So let's fix this thing. What is this? This is 240 ohm, 25%, 0.42 amp. Let me grab. Be right back. All right. So what I've got here is a strip of these. Are these the right size? Let's just pull one out and see. I think they are. Did I lose it? I'm so bad about losing these things. You will notice that, yeah, that's going to be the same package size. So let's set that aside. All right, so let's fix this thing. You will notice that I am starting to use far less donor components, and the reason for that is because eventually you run out of donor components. So I have turned to sourcing a lot of these smaller components from DigiKey. You know, a lot of these little filters and capacitors and things, you can order them for, you know, just a few cents a piece. So let's replace this one with a new one, because it saves me a shit ton of time digging one off of a donor board. So what I'm going to do here, I'm going to put a little bit of flux on here. Now, this is foreign territory for me. This is not a component that I've ever replaced before on an iPhone 7. Haven't dealt with this before. I don't know the thermal mass of this board, and also I don't have another one to test run this on. So once you've been doing this long enough, you get a level of confidence about you to where this isn't going to be an issue. What I'm going to do is I'm going to use my hot air to raise the temperature of the board up a bit, and then I'm going to use my micro pencil to sort of flash heat just that component, and it's going to come off in a puff of smoke. So let's see how this goes. That's my plan anyways. See if it works. Are we in focus? Ah, it's focused on the screen, but not for my eyes. Time for some microscope maintenance. Alright, so board is just about heated up to where I want it, and I'm going to touch this filter with my 2032 microscope with the 0.1 millimeter conical tip. Do not make me look like a fool on my YouTube video. Alright, so that is out of there. And I am just about to order that station. I think I've decided to go ahead and just go with a either another FX951 or I might do an FM203. Was really tempted to go on up to JBC, but I just... Can I get this micro pencil down in there? I just don't... I don't think that I would wind up using the tweezers often enough. Okay, we got a little pillow on that pad. This is really tricky because we're in tight quarters here. I don't think I'd wind up using the tweezers often enough to justify the $1,300 rework station. I do like the features it has, like it'll work as an alarm clock and like turn itself on for you. And I think it'll even do different temperatures at different times of the day. But honestly, I feel like I'm still going to wind up using the micro pencil most all of the time. In which case, I like my 2032. There we go. We've got a, yeah, you know what? This is an important line. Let's make sure we got it. Yeah, you know what? Nitpick. That'll teach you. I think I just pulled the solder right back off of that pad. You know, so a lot of this stuff is just broken connections, and if you look for it hard enough, we're going to call that good. I think. Not yet. If you look for all of the connections and find the one that's broken, many times you will send your customer out the door happy. Alright. So, we're going to accept that. And now I'm going to float a new one on here with hot air. Yes, it took me a long time to begin sourcing components. I have been running on donor boards since the beginning of time. But now it's like there's not a board left that has a single cap that I need for the 5V7 chestnut lines. There is not a single filter left on any of the boards here, and I've got piles and piles and piles of them. If the coughs are too loud, I might edit it out. This is awful. This head cold has been awful. I hardly ever get sick, man, but when I do, it sucks. Alright, so we want to be excruciatingly careful here. I think I just seen that start to jump. I'm going to heat it one more time to straighten it, but I'm going to do it very carefully. Looks good. We're going to stop right there. You know, when you're working on a board that's totally foreign, and you don't know exactly what you're up against, you have to be really, really, really careful with heat, because it can be the difference in night and day. Like if you've done nothing but iPhone 6 TriStar ICs for a week, and then you jump in and you try to micro solder on something that heats this easy, you just bake it. So I'm going to take a quick break and deal with my head cold. This is terrible. I hate this. Okay. Maybe we'll skip that break. While this board is hot, I'm going to alcohol and toothbrush this off. I could just Q-tip it, but let's use alcohol and toothbrush today. I'm just glad I didn't have to unsolder a shield on one of these. They're not that bad. If I have to unsolder an iPhone 7 shield, which I've been doing here lately quite a lot for data recovery, I wind up taking and I cut right here. Instead of peeling the sticker off, I actually make a cut across their sticker right here. And because I don't think you can really peel this off with any real success. So Okay, I'm going to have one more look at this area under the microscope. It looks like garbage, so we're going to heat it right back up a little bit. Not enough to melt solder, but I'm warming this board back up hot to the touch, because I don't like sending these things out with flux all over them. I think it's nasty, it's sticky, it's ugly, and I take pride in sending out clean work. So well, that looks this PCB looks pretty close to factory again. I'm pleased with that. It don't have a bunch of gunk all over it. And although we had 1.8 volts at the 1.8 pin, a 1.8 volt pin on the connector, we still didn't get an image on the screen. And I'm thinking what happened on this one. I haven't tested it yet, so I might just be totally full of shit. I'm probably full of shit anyway. Ah! How many times I've done that? Forgot to peel our sticker off. Okay, so I'm thinking what probably happened here during this injury is that a screwdriver or pry tool or something came in contact between the screw hole and the hot side of this 1.8 volt capacitor on that line. And since it was on the connector side of the filter, you wind up in a situation where the filter goes poof. So here is that. I'm probably going to have to sit and edit out all these coughs to keep from getting a bunch of dislikes. Okay. So what we've got here, FL3906 was blown. And if we switch over to Blackfish, and we're going to look for FL3906, we find PP1V8 here. Where it comes out, it goes through FL3906, and it pops up as PP1V8 LCM CON, which is needed to provide power to the display so that the display can turn around and hand a little power back to Chestnut and say, hey, I'm here, turn everything on. And that's what gets the whole thing started. So if we switch over and look at ZXW tool on the top side of the board, here is that line here at the connector. If we trace it out from the connector, we get out here to this cap that's right up against the screw hole that's just been annihilated. And I believe we wound up getting a short between here and here. And when that happens, we get 1.8 volts here to ground, which leaves FL3906 here. Little FL3906 can only take 400 milliamps or whatever this one's rated for. And it smoked it. So it still had enough conductivity. It was still a good enough conductor to get us 1.8 volts to the connection to the connector, but from the time you start to put a little bit of a load on it, like if we would have checked it for 1.8 volts with the screen powered up, did I check that? If we would have checked it for 1.8 volts with the screen attached and the phone powered up, I don't think we would have gotten 1.8. We would have gotten something less because it would be getting pulled down. So let's see if I'm full of shit. Let's put this back in the housing. There's our iPhone 7 PCB. There's our housing. We're going to hook up this ribbon up here. I believe it probably has a power button in it. We're going to hook up our dock connector here because it probably has the dock connector in it. I'm going to go ahead and plug in the camera connector because I don't want anything goofy shorting out and trolling me and running me in circles thinking that it's something else like long screw damage. I'm going to go ahead and do the same on this little connector here. I would like it to be hooked up. You know, it's not necessary to hook a lot of these up, but I don't like for things to be laying around that could potentially touch and become a conductor and trolling me. So, let's go back to my screen. Oh, I'll never get used to the way these ribbons are. I should probably get me a test cable. Alright, so we're going to hook my screen here. And just in case we still don't get an image, I'm going to hook up the power supply. And that's the way I tell whether or not the phone is actually booting. There we go. Okay, and so that you can see current consumption, I'm going to switch you over like this. You should be able to see the screen. You should also be able to see the current. And I'm now pushing the power button, which by the way feels unusually firm. And we get Apple logo. Now I don't think it's going to fully boot because this power supply is a steaming pile of garbage. Also, some of them seem to have issues with not having the data line hooked up. You know, sometimes they'll fully boot, sometimes they won't. But I can tell you, this power supply, you get a little tiny little bit of a chirp. You can hear it make, and I bet you if you hook this thing up to an oscilloscope, when you start hearing the pulse width modulation, when you can hear it, I just bet you're going to see that ripple on a scope. So I've never done it before because it would probably just scare the shit out of me. I am going to go ahead and hook up the customer's battery. And then I'm going to drag over a charger. We're going to plug in the charger. Now I am using a USB amp meter here for like the first time since ever, and we're getting about an amp of charging current. So this thing is actually drawing a charge. And we're going to let the phone boot. Now while that phone boots, I don't want to show anything revealing, so there we go. Dun, 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 dun. I sure did think that was going to be long screw damage, didn't you? You know, something to do with the screw hole just like completely, totally ripped off the board. Just for some reason I thought it was going to have something to do with long screw damage. I don't know why. Any minute. We're still on Apple logo. Hey, still waiting. Please don't sit there and hang on an Apple logo indefinitely. That would complicate my no image repair for sure. Yay, charging tone. Alright, I don't see anything incriminating on the screen, so I can show you that this screen does absolutely, positively, and totally work. We're up to a passcode. And we're going to go ahead, I'm going to go ahead and slide the power off. I don't know if I have a passcode for this one, but I am going to say that this is going to be, let's see. I always do this. I get to the end of the video, and I wonder if I'm going to continue. And to be completely honest, just now when I did that slide to power off, I thought I may have seen a hint of something that made me think that this was going to have a section of the backlight missing. So I'm going to power this phone right back up and see what it'll do. So let's power this thing back on. I'm going to unlock the screen. I'm going to go full bright with it and make sure we've got a good working display. I will call an end to this video, and then the next thing that I do to this phone will be to reassemble it using his screen, and I'll just do a basic checks of the mics, cameras, and speakers to make sure everything works, because after any repair, no matter what it is, it's a really, really, really good idea to check all that stuff. If you don't, it's going to go back to the customer. They're going to unbox it. You know, even if it just showed up to you for a backlight repair, well, if they get it back and the ear speaker don't work, you know, they're excited. They get like, finally got their phone back, finally, and they get it out of the box and everything's great. Yay, the screen lights up, but I can't hear anybody when I talk on it. You know, that stuff can be a really, really, really big drag. And yeah, it's not, you know, you weren't hired to fix that, but sometimes you just gotta suck it up. So, dang it, I thought I'd talk long enough to get past this Apple logo. Seems to boot a little slow. Isn't this iPhone 7 supposed to be fast? Come on, Apple, get it together. Alright. Okay, here we go. Okay. We're going to set it full bright. pull down notifications. No issues here. This phone's good to go. No screen issues anyway. So the next step from here is to fully reassemble this phone using a screen assembly that has all the guts. That way I can make sure everything works before it goes back to the customer. So, man, it's been a minute since I recorded a video. I've already been on vacation and back. Nobody even noticed me gone because I've really been kicking ass and catching up the job queue. So, guys, before I say something that ruins this video, I'm going to call an end to this and move on to my next repair. So, I hope you all have successful repairs, and I really hope you have a good day. Thanks for watching, everybody. I'll see you next time. Alright, I'm just finishing up the no image iPhone 7 here, and I'll probably clip this into the end of that video. I didn't think it came with all these screws and stuff, but then just before I pack this up as done, I found them hooked to the back of the old screen assembly, which I think confirms that this one was in fact no image after a screen replacement. Okay, there's our pintle loops. This is our battery retaining clip here. And there's this one. So let's put all this stuff back together. And then we're going to test it. Screws stuck all over the place. Alright, can you see it? I think you can see it. Okay, so I'm not a whiz at the iPhone 7 yet. I still have a little bit of a struggle holding everything in place while deciphering the correct screws. This one looks pretty long, so we're going to put it back here. We're going to put that in the tiny hole, right? Yep, that one did indeed. Let's see, if I turn this, you might be able to tell what I'm doing. So I just put the long one back there in that hole. Now, remember, these screws came to me in a bag. Like, and we can look at this one and clearly see how short that it is. So that's a screw that I consider short enough to put into this hole. Okay. Now we're going to pick us out another very short screw. And go with that hole. This hole's tore off, so we're not going to be putting anything back in there. And I really should test this thing thoroughly before fully reassembling it, but I did microscopic evaluation on all those traces, and it actually looks acceptable. So let's see if we can figure out which way this little plate goes. Since I didn't take it out, it's a little bit tricky. Okay, so if we were to flip it around, it wouldn't fit that way. It wouldn't fit that way. That leaves one way that this could possibly go. See, I'm not just cramming this back together. I don't know which way this goes, but I'm still just not going to cram it back together. I have worked on, just today alone, so many iPhone 6 Pluses that have literally just been crammed back together. Like, they took it apart to try to fix Touch IC issues and didn't remember how to put it back together. So it literally got crammed back together with connectors under the board and stuff. And if that wasn't enough, then they bolted it down, like cranked the screws down on top of it real good. Alright, so we got that one. And also, since I am dealing with screw holes here that have PCB underneath, I am being excruciatingly cautious of the screw length. I mean, because, you know, yeah, this one wasn't long screw damage, but, like, come on, the screw holes tore off of it. It is physically long screw damaged, but it's not electrically damaged so far. Let's see if it passes. So, we have all those screws back in, I hope. And we do top corner first, right side next, and then we should get couple of nice little pops here. And I'm so used to, after I'm done popping the screen in, home button check, and this one, you know, it's solid. It's an iPhone 7. So let's go ahead. We did verify that the customer's battery was enough to boot this thing. I'm going to go ahead and plug this in, boot it up. We're going to uncover Man, look. See the round? This up here is due to long screw damage of the screen. I was asked, I've been asked a few times if only the iPhone 6 and 6S suffer long screw damage. And also, I think this boots faster with the screen assembly being complete. And the truth is, you can long screw damage a toaster. And this is proof, because this screen has actually been long screw damaged. It's got a mark where... Oh, this is terrible. Amateur photographer here. You can see where the screw came through and touched the glass. So let's go ahead and unlock this thing. What we're going to do, we're going to test this thing for functionality. Okay, screen unlocked. We have working touch. The first thing that we're going to do in a situation like this, we're going to check there's back camera, there's front camera. That passed. The home button passed because it clicked. I am going to bring up... I seen a ghost click there. Did you see the ghost click? That might have been from the wrapping on the screen. Now, since the touch ICs on this phone are actually on the screen itself, right? Or did they move it back to the phone? No, they're on the screen right here, clearly on the screen. If we wind up with issues with finicky, weird, ghosty touch, 99% chance it's a faulty screen. If you wind up with full-on touch or no touch, it's probably going to be the phone. So here we go. We are going to record. Check proximity sensor. Proximity sensor works. All right, we're going to stop. We're going to check the ear speaker. Ear speaker works. Loudspeaker. Try loudspeaker again. Okay. All right, loudspeaker works. Alright, we're just going to delete this memo. Delete that memo. We are going to go into, now we're going to go into settings. Provided I can find settings. I don't know why I always look for so long before I just go type it into the search box. I should just do that every time. Alright, so here's settings. Wi-Fi. Wi-Fi works. There's my upstairs network. Go back. We're going to go down. We're going to check Touch ID. We're just going to go to add a fingerprint. No problem with Touch ID. Let's see. Something about accelerometer, right? That little happy little chip right there next to it. Let's use the camera to test the orientation sensor. Okay. Camera rotates, no problem. This phone's going to be fine. Although it did have the screw hole completely ripped off of it, it's unrelated. Like, the problems that this thing had was from the 1v8 filter being shorted to ground. So, for real this time, that is going to be the end of this video. I am putting this in the box to charge here. And I'm going to get this customer an invoice because I like successful repairs. That is what keeps the bills paid. I'm just trying to drag this out a little bit farther so I can finish my repair video. It's not finished until it has the pentalobe screws in it. Ah, done. Time me. Alright guys, thanks for watching. I'll see you next time.